Hello, my name is Ardi and we are going to solve this problem here. The question is find the value of RL for maximum power transfer. Okay, the keyword here is maximum power transfer. In the circuit of figure 4.50, this is the circuit here, and then we need to find the maximum power. There are 4 steps here. The first 2 steps will be finding the Thevenin equivalent circuit. So we need to find out the Thevenin resistance first. We need to find the Thevenin resistance, RTH, here. And then the second one will be finding the Thevenin voltage, which is VTH. Good. And then the third one is find the value of RL, which causes maximum power transfer. So this is the third step. And then the fourth one is to find the maximum power itself, which is find P max. Okay, there are 4 steps to solve this circuit. Okay, let's do the first one. Here, we need to find out the Thevenin resistance. And to do that, we need a new circuit here by turning off the sources, right? So we need to find RTH. And that means that we need to turn off the sources. Okay, and how to do that? If we have voltage source, so we'll have voltage source. We replace it by short circuit. So we replace this one here, this 12-volt voltage source by short circuit, and then we replace this current source here by open circuit. So we'll have current source replaced by open circuit. Okay, and also we need to take off the RL here because this is the load. Okay, so take off. Good. Now let's redraw the circuit here. We will have this 12-volt voltage source replaced by short circuit like this, and then we will have that 6 ohm resistor. So we'll have this one 6 ohm here, and then we will have this one here. We will have 12 ohm resistor, which is this one here. Good. And now we will have that 3 ohm resistor. And then we will replace this 2 ampere current source with open circuit. So we don't have anything here because it replaced by open circuit. And then finally we will have this one here. We'll have that 2 ohm resistor. Good. And this is terminal A and this is terminal B. What is RTH? As RTH is, oh, that is B, not A. A and B. So this one is terminal A and this one will be terminal B. So in order to find RTH, it is the equivalent resistance seen from this point here. So we'll have RTH is this one. Okay, let's calculate that. So RTH is, we have this 2 in series with 3. So we'll have 2 plus 3. And that will be in series with the 6 parallel with 12. So we'll have 6 parallel with 12. Okay, now let's simplify things. We will have 2 plus 3, that is 5. And then this will be 6 multiplied by 12 divided by 6 plus 12. Okay, and that will be equal to 5 plus 72 divided by 18. Okay, and 72 divided by 18 is just 4, right? That will be 4. 5 plus 4 is 9 ohm. So we'll have RTH is equal to 9 ohm. Okay, and that is the first most important value that we get. From here we get the RTH is equal to 9 ohm. Okay, and let's save this. And we need to move on to the second step, which is finding the Thevenin voltage. Okay, let's clean up our board. Okay, the second step, we will need to find out the Thevenin voltage, which is find VTH. What is VTH? VTH is the open circuit voltage at AB, right? So we'll have this open circuit voltage at AB. So we need to take off this RL here. Okay, let's do exactly that. Let's redraw the circuit. We still have this 12 ohm resistor, 12 volt voltage source. And then we also have this 6 ohm resistor, 6 ohm. And then we also have this 12 ohm resistor. Then we still have this 3 ohm resistor. And then we still have this 2 ampere current source. Okay. And then we still have that 2 ohm resistor here. 2 ohm. And we have open circuit voltage here. So the Thevenin voltage will be here, this one between A and B, VTH. However, we need to change a bit here because there will be no current that goes through this 2 ohm resistor because the current has nowhere to go here, right? So the voltage here will be equal to A here. So we can just replace this 2 ohm with short circuit, like this. Okay, and I think that's good. Now we need to do circuit analysis. Okay, how to do that? I think we need to name this here as node A. And let's set this as our ground. So the voltage here will be 0. And then here we will have, maybe because this is terminal B, let's set this up as terminal C. And this is 12 volt from the ground. So we have 12 here. Let's assume the direction of the current. So we will have this goes there, this goes here, and this maybe I want it to go to the left, and here I will have this goes up like this, right? Okay, I think we can calculate the voltage at C first. Okay, because from here we can calculate A, right? Because the current here will be 2 ampere, right? This one and this one, that will be 2 ampere, right? The current here is 2 ampere because this is current source, and current source in series will be 2 ampere. Okay, so we need to do KCL at node C. KCL at node C. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, that is good. Now we will have 12 minus VC here as one of the current that goes in. 12 minus VC divided by 6, right? Where the current comes from and where the current goes. 12 minus VC divided by the resistance between them, which is 6. And then this current also goes in, so we'll have plus 2. Good. And then that will equal to this current here, which is VC. And it goes to the ground, so we'll have minus 0 divided by the resistance between them, which is 12. Okay, get rid of that 12 by multiplying both sides to 12. And 6 and 12 will cancel into 2, so we'll have 24 minus 2 VC. And then plus 24 here. And that will equal to, we'll have 12 and 12 that will cancel each other, so we'll have VC here, and then we will have 48 is equal to 3 VC, and that means that we will have VC is equal to 16. But then we can also calculate VA from that. How? Okay, let's do that. We will have I here is equal to VA minus VC, VA minus VC divided by the resistance between them, which is 3. Good. but then the I here is 2 ampere. So we'll have 2 here, and we have this VC is equal to 16. So we'll have 16 here. 16. And so we will have 6 is equal to PA minus 16. And then we will have PA is equal to 22 volt. But we need to calculate VTH. But then VTH is equal to VA minus VB, right? VA minus VB. But in our case here, VB is our ground, so that will equal to VA. Therefore, we have VTH is equal to VA, and in our case, we will have 22 volt. Good. So now we will have this second step done. So we will have 22 volt as the Thevenin voltage, and then 9 ohm as the Thevenin resistance. Okay, let's do number 3 and number 4. Okay, let's do number 3 here. So we need to find the RL that cause maximum power transfer. And that should be easy enough because RL that causing maximum power transfer is just the RTH. So RL is equal to RTH, and we already have the RTH, so we will have 9 ohm. So here we will have 9 ohm also. Okay, and we have done the third step, and finally we need to find out the Pmax. Number 4, find Pmax. And remember, the formula of Pmax is equal to VTH squared divided by 4 multiplied by RTH. Good. We already have the VTH here. VTH is 22 volt, and that will be squared, and then divided by 4 multiplied by RTH. RTH is 9. Good. And I think this is the task of our calculator. Let's get our calculator ready. And we will have it here, and we can just plug the number. So we'll have 22 squared divided by 4 multiplied by 9. And we will have 13.44. 13.444. And then the unit, because we have the volt, ampere, and ohm, the unit of the power will be also in SI unit, and the unit of power in SI unit is watt. So we will have this one will be 13.444 watt. And we have done all the steps required to solve this problem. And this is the final answer. Thank you for watching, and see you in the next video. Bye bye.